For y'all that have been with me the whole time, this is the actually the last part of Chapter 5. So in this, we're going to end up with our chemical equations and reactions, and we're going to talk about what's called a limiting reactant. So a limiting reactant is the reactant that is going to be completely used up in a reaction. So if I have a limited amount of one thing, I'm going to have what's called an excess of something else in my reactants. So in this equation, I need 1 mole or molecule of A added to 1 molar molecule of B to make 1 mole of compound AB. So I need 1 of each of these reactants. But I don't always have exactly 1 and 1, as we've seen in our other calculations. And so an analogy for this is if I was going to make a bologna sandwich. So if I'm going to make a bologna sandwich, I'm going to say and define that I need 2 pieces of bread for every sandwich and 1 piece of bologna. I always wondered why they could spell it like that, but anyway. Alright, so I need 2 pieces of bread and 1 piece of bologna, and if it was me, I'd need some mayonnaise. Okay, so if I start out, I've got 3 pieces of bologna, and I've got 1, 2, 3, 4, 5, 6, 7, 8 pieces of bread. So I've got 8 pieces of bread and 3 pieces of bologna. Well, if I'm going to make a sandwich, then I need 6 pieces of bread for every 3 pieces of bologna. So I'm limited as to how many bologna sandwiches I can make by the bologna, because I only have enough bologna to make 3 sandwiches. I have enough bread to make 4 sandwiches because I need 2 pieces per sandwich. So I make my 3 bologna sandwiches, and I have bread left over. So my bread is my excess, and my bologna was my limiting. And so I can only make as many sandwiches as I have the least reactant. So that limiting reactant limits how much I can make. I have bread left over, but I can't make another sandwich with it because I don't have another piece of bologna. So in chemistry, we are going to apply that with our moles and molecules, or how we want to look at it. So determine how much of one reactant is needed to react with a second reactant. So in the balanced chemical equation, I need 2 hydrogens, 1 oxygen, and to make 2 waters. Okay, so there are 4 molecules of hydrogen and 2 molecules of oxygen, and then it's going to make 2 molecules of H2O. So I know my conversions from my balanced chemical equation are going to be 2 hydrogens for every 1, because 1 is understood, oxygen, and so I can put that into my calculation. 4 molecules of H2 times 1 molecule of oxygen for every 2 molecules of H2, and that's going to give me 2 molecules of O2. Okay? So if the amount present of the second reactant is less than what I need, the second reactant is limiting. If the amount present of the second reactant is greater than what I need, then it is the excess. So if I had 4 molecules of hydrogen and 3 molecules of oxygen, then I would have how many waters? Well, I'm going to use up these 4. For every 4 of those, I need 2 of these. So I could make 4 molecules of water, right? So if I make 4 molecules of water, I've used up all 4 of my hydrogens, but I only used up 2 of my oxygen, so I had 1 left over. So whatever I had left over, that's my excess. Whatever I used up is my limiting. Using the balanced equation, determine the limiting reactant when 10 grams of nitrogen, whose molar mass, is 28.02 grams per mole, and we react that with 10 grams of O2, that the molar mass is 32. So I'm starting out with 10 grams of nitrogen and 10 grams of O2, and it wants to know what is the limiting reactant. So the easiest way to do this is figure out how many moles you have first. Okay, so if you've got 10 grams of nitrogen, we know we can say 1 mole of nitrogen over the molar mass of nitrogen, which is 28.02, gives us 0.357 moles of nitrogen. 10 grams of oxygen times 1 mole of oxygen and its O2, that's why it's 32 grams instead of 16, is going to give me 0.313 moles of oxygen. So if you multiply 0.357 moles of nitrogen times 1 mole of oxygen over 1 mole of nitrogen, because those have to cancel, you get 0.357 moles of oxygen needed. The amount of oxygen we started out with was 0.313. That's less than the amount we would need, which was 0.357. So I'm going to be limited by that. I'm going to be limited by the oxygen.